process will be naturally faster because we've already kind of experienced a little bit of trigonometry. So we're looking at two things today, sine and cosine. So if you go back to our fancy acronym, yes, some old hippie caught another hippie. So those are the two functions we're going to look at today, and we did tripping on apples yesterday. Alright? Now, the good thing about trig is you have infinite options based on what the triangle is giving you. So, sine is equal to opposite over hypotenuse. So sine is the trigonometric ratio of the opposite side over the hypotenuse. Cosine is equal to the trigonometric ratio of adjacent over hypotenuse. So both of these functions use hypotenuse. Hypotenuse is always the denominator. It's just distinguishing which one is opposite, which one is adjacent. So I want to find the sine of A, and I want to find the cosine of A. Just write the ratio. So I'm going to set it up. If I'm evaluating the sine and cosine of this angle, what is sine? So what is opposite of A?
X.
What is the hypotenuse?
H.
Now cosine of A is adjacent over hypotenuse.
Y.
We did a lot of the work yesterday. And just for fun,
X over Y.
so tangent is really sine divided by cosine. Alright, that's going to be huge for later. Let's go ahead and knock out the sine of B and the cosine of B. So now we're using this angle up here. So what is sine?
Y over H.
Opposite over hypotenuse. And what is cosine?
X over H.
And just for fun, the tangent of B.
Y over X.
So just to make my point. And what else do you see? What?
Denominators in the same?
No. The sine of A and the cosine of B are the same thing.
That's good.
So,
I'm glad that's a thing.
what?
I'm glad that's a thing.
So it is a thing, but if you accidentally try to find the sine of A and you find the sine of B, you're really finding the cosine of. Yeah, it's weird. So like, just be careful when you're doing stuff. So just try it one more time. This is just set up the ratio. This is on your paper. Set up the ratio. What is the sine of A? The sine of A?
It's 12 over 15. And 900.
What?
Cosine of A is 9 over 15. And then flippy flop. 9 over 15.
So now as we flip to the sine of B, the sine of B is 9 over 15. And the cosine of B is 12 over 15. Are you just really good at this, or am I going really fast? Because it feels very fluid today. You good?
Yeah.
Dude, I'm running on
I
like
can
3 hours
actually
of
did
sleep
the stuff
in a row.
yesterday, so I was like, oh, that's how you do it.
All right, one more time. So we have a different triangle. I'll slow it down just a little bit here. There's x. So the sine function is listed as opposite over hypotenuse. Now, what is your hypotenuse?
25.
Right? Every sine and cosine function has the hypotenuse as the denominator. So the sine of x, what is opposite of x? Cosine is adjacent over hypotenuse. Now, as we flip to y, now what is opposite of y? Alright, so just take a small break here. Is there some sort of numerical pattern that you see based on all of our ratios for sine and cosine? No. Beyond that. Beyond the repetition or the symmetry of them. Come on, draw a connection. Huh? No. I'm not asking about the relationship of these numbers. I'm asking about what pattern do they have individually. You're on the right track. Okay, so let me go back to the last one, see if you can draw a connection. What do you notice about all of these numbers and all of these numbers?
Mirror.
They're all less than 1.
Oh.
They're all less than 1. Every single sine cosine ratio should always be less than 1. Period. So that's a good way to check yourself. If you find a ratio that's bigger than 1, you're wrong if you're doing sine or cosine. The only trig ratio that can be greater than 1 is tangent. It could be less than 1 or it could be greater than 1. So today I'm not going to go through the whole worksheet and set them up and then go back and solve. Today we're going to set up and solve simultaneously because you already know all the tricks. So this is weird. You have an angle and you have 2 different trig functions to pick from. So you have to say, what angle are you looking at and what do you have in relationship to this angle? You have an opposite, you have a hypotenuse, so you should use sine function. So I'm looking at the sine of 50 degrees, and it's equal to
X over 15.
opposite over hypotenuse. Student responds with
Then you
15 gets a fast pass to the front.
It all follows the same rules.
Yeah, it's the same thing. 15 sine 50. 11.491. They all follow the same rules. It's just a different function. Now, I want to nerd out just a little bit to prove a point, and then we'll continue on. What if I was to put a variable there?
then you could do tan.
No.
No,
Okay. Yes, Blake, you're right. Blake is, I can use tangent here, but do I want to use trig for a number that I've rounded?
No.
No, that's a terrible idea. So I could use cosine.
Oh.
Because they're all given values, which would be
Oh, the same.
what's that?
They're the same.
They are not the same. Watch.
Cosines.
15 cosine 50. Oh man, that's a 9.641.
It's actually 6.2.
Oh, 9.642. You're absolutely correct. Come on, Baker. Yes, ma'am.
How do you get the radians and degrees again?
Oh, I can't see. Alright, I'll show you guys. I forgot. Bad Baker. Make sure your calculator's in degrees, or you can do everything we've been doing, getting different numbers.
Yeah, we're doing like negative.
Yeah, because you're in radians. So it's like you're trying to do 50 radians, which is like 2, 4, like all the way around the circle like 14 times. Doesn't make any sense. So home 5, 2, home 5, 2, and then this angle should say degrees right here, and then hit make default. And then to get back to your deal, you just hit 4. So here's something I want to prove. Now that I have a triangle, that is a right triangle, a squared plus b squared should equal c squared. I'm excited. 11.4907 squared plus 9, no, I'm going to cheat, plus 9.64181 squared should equal 15 squared. So a squared plus b squared equals c squared now. I think that's awesome. Cool. Whatever. Alright, what we have here? Cosine. So cosine I think is easy to see because everything is right next to each other. Okay, someone taught me this. It's like a C, it makes a cosine. Right, that's kind of a really stupid trig. I don't know if it works for you or not, but so the cosine of 63 degrees is equal to 5 over x. And then yesterday we talked about what happens when there's a variable in the denominator.
Don't they switch the variable? So
So
it's 5 over.
The trig function and the variable switch locations.
So it's 5 over cosine. Oh, I actually did that right.
So that's where I like to use the control divided by 5 over cosine of 63, 11.013. How are you feeling? Alright, so this is just one of those things where I can't really make it very pre-AP. The only way to make it pre-AP is to make it radians next week.
No.
Which I think is actually easier than this. I personally feel that way. And you don't know why yet, but when we get there, you'll be like, alright, Baker, we got you, bro. Okay? Just celebrate success while you have it. Let's just put it that way. How do we set this one up? Fast pass to the front. I trust you. Alright, so a lot of heads down. It's kind of almost turned into independent practice at this point, right? You're like, how many guys are already ahead of me? That's what I figured. So I'm going to skip the rest of these because I think you're confident with them. Now, the only other scenario is. What's the scenario? Where we start for number 15. So let me teach you this last one and then I'll set you free to practice. Okay. What happens here? You still do the same thing. Okay. But what is the trig function we have to use here? The sine of x degrees is equal to 15 over 20. And I told you guys yesterday, when we're solving for an angle measurement, you have to use the inverse of the function, or homie goes to the other side of the tracks and loses a life. So just to show you where it is, I'm sure you've already found it. We're going to do trig again, but we're going to pick inverse sine of 15 over 20. And you get 48.59 degrees. Yeah? What? Well, that's pretty much the last thing I can do. Everything else there is there anything else on those examples that is like weird or trying to you? So, I do want to give you one more example, then I'll cut it for the day. So, pay attention to this one. I'm going to speed past all of these to a blank slide here. Well, you don't just watch. Okay, so what trig function do you want to use to solve for something?
Well,
No, you can't use Pythagorean. I don't want you to use special right triangle tricks either. Sorry, Aaron.
you could do sine, you can do cosine.
That's what I'm after. In this scenario, you can use any trig function you want. Does that make sense? So with the regular kids, I say the sine of 30 is equal to opposite over hypotenuse. You can solve that. The cosine of 30 is equal to adjacent over hypotenuse. That's the only one that will not work right there. The tangent of 30 is equal to opposite over adjacent. So all of those functions besides this one will produce an answer. But if you flip to the other angle, the sine of 60 is equal to opposite over hypotenuse. That one doesn't work, but cosine does. Cosine of 60 is equal to adjacent over hypotenuse. And tangent of 60 is equal to opposite over adjacent. So you can set up 6 functions and 4 of the 6 should work depending on where the variables are. It's great because you pick one you like and you run with it. If it doesn't work, just pick your second favorite. So I'll give you the rest of the day to practice that. It is just purely practice, practice, practice. You can practice in the front, you can practice in the back. You have a calculator to practice with. Tomorrow I'm just going to give you the whole day to practice all 3 mixed together. Alright, so you'll have some sine functions, some trig functions, some tangent functions. You'll practice all of those, and then Friday we'll start the law of cosines. You want to see what that looks like?
Sure.
Here's what it looks like. So that is the law of cosines. Now you're asking like why is the law of cosines even there? The law of cosines will solve for a triangle that looks like this. What is different about that triangle as opposed to every other triangle? It's not a right triangle. So trigonometry will work for non-right triangles. So it's just a different application of the truth. Alright? Then we'll look at the law of sines as well. Then we'll start playing with radians. And the next thing you know, you'll be taking your test. It's going to be great. Hey, let me pause this real quick so I don't ruin anything.